All right, we're doing section 7.2, which is the volume, finding volume of a function that's flipped over an axis, and we're going to start with the disk method. So if we have an axis of revolution, so let's say that we have some sort of rectangle, the height is your r and the width is your w, and we're flipping it over the x-axis, what you would end up with is something that looks like a cylinder, like shown below. So the way we're going to find that is there's two different ways to use the disk method. The first one is when we're flipping it over a horizontal axis of revolution. Okay, so it should look pretty much the same. So for the horizontal axis of revolution, you are going from point A to point B. Your rectangle is going to be perpendicular to your axis of revolution, so it's going to look like this. And your r, the height of it, is going to be whatever your function is. That's your r of x. If you're flipped over the horizontal axis. In the other case, if you're being flipped over the vertical axis of revolution, the rectangle would be the other way if we're flipping it over the vertical. So you're perpendicular again. You're not going to have A and B. You're going to have C to D on the vertical axis, and then your r of y, not r of x this time, your r of y is going to be your other function. So just be really careful when we're flipping over the y-axis. We need our function to be in terms of y, so we need to solve it for x first. Okay, so we're going to find the volume of a solid formed by revolving the region bounded by the graph of sine of x. We actually need to change that to the square root of the sine of x, and the x-axis from 0 to pi about the x-axis. So our function looks like this. From 0 to pi goes up to a height of 1. So what is our r of x? What is the height of a rectangle? If we were to draw a rectangle in here, perpendicular to our axis of revolution, our r of x is the function itself. So to follow the formula, the volume is pi times the integral from a to b, or a to b this time is 0 to pi, of our function, our r of x is the function, square root of sine of x, quantity squared because it's r squared, dx, and the square root cancels. Take the integral. It's negative cosine x from 0 to pi. And when we evaluate this, it ends up being 2 pi. Now that's going to be our volume. What our solid would look like, this is kind of cool. Okay, I'm not the best at drawing 3D objects, so it would be this, it would be like a football, and it would be flipped over the x-axis, so it would be a solid. So picture this solid of revolution coming from our original function. Okay. Next, we are revolving around about a line that is not a coordinate axis. So this time we have a solid formed by the region bounded by 2 minus x squared and 1. So here's 1. The line y equals 1, and 2 minus x squared looks like that. So how are we going to do this? Well, this time we find out what our intersection points are because we are not given any bounds. They intersect at -1 and 1, so that's what our bounds are going to be. But now we need to figure out what our r of x is. If we're flipping it about the line y equals 1, we're going to have to figure out what this area is in between, because our r of x is not just going to be 2 minus x squared. It's actually going to be r of x. It's actually going to be 2 minus x squared minus 1 because that's what the area inside that is. So similar to what we did in section 1, finding the area between those two curves, we need to find the area between them before we can find the volume of it being flipped. So we need to include that 1. So our r of x is actually 1 minus x squared. So our volume is pi times the integral of negative 1 to 1 of 1 minus x squared, quantity squared, dx. And if I FOIL that out, 1 minus 2x squared plus x to the 4th. And we can take the integral. X minus 2/3 x cubed plus x to the 5th over 5, evaluated from negative 1 to 1. Which ends up being 16 pi over 15 when evaluated. Again, let me just show you kind of what this would look like if it was flipped. Okay, so here's y equals 1. So pretty similar to the last one. It would be kind of like a football flipped over the line, y equals 1. Okay. What I think we're going to do is take a pause, and then I'm going to have another video because I don't think we're going to get everything in on one. So I'll just have the first video be about the disc method and the second be about the washer. So watch the second video for section 7.2 to get the washer method.